Question 7 is going to be a little bit more challenging to show in this format. So I'm going to approach this a little bit differently than I might normally approach this problem, just for the ability to be able to explain it here. So what we have here are 5 infrared spectra. At the end of this section, at the end of this question, there's 12 possible structures. So what we're going to do here is unfortunately going to be a lot of scrolling back and forth. But the way I'm going to approach this is that on each one of these spectra, we'll look at the spectrum, see what's important in the spectrum, then we'll scroll down to the possible structures and see where that leaves us. So this first question, first spectrum, the first thing we see is this group of 2 peaks right here. Anytime we see that group of 2 peaks together like that, that's a sign that we're dealing with a primary amine, an NH2 group. As for whether this molecule has any carbonyls or not, it's not completely clear at the moment because we have something here that's in the low 1600s. So the initial instinct would be to say that no, there's probably not a carbonyl in this molecule. But right now I'm going to scroll down to our 12 possible structures and look for anything that has an NH2. And as you can see on our list here, there's just a single compound that has a primary amine in it, and that's compound D. So therefore, we know that this first spectrum is the one with the primary amine, which is, again, compound D. Alright, let's look at our second spectrum. So the things that jump out to me in this second spectrum is, first of all, there's very unlikely to be any sort of NH2, NH, or OH groups, because that region is almost completely empty. The next thing I see, though, is this peak here. Again, we can see that's in the mid 1600s. It's medium strength, so not likely to be a carbonyl. To me, this looks like an alkene peak. So again, let's scroll down to our possible compounds. And where do we find alkenes? Well, we find an alkene here in B, and we also find an alkene in compound I. The compound I also has an alcohol. And if we go back to our spectrum here, we can see that there's clearly no alcohol in this compound, leaving us with B as our only possible answer. Our third spectrum, the first thing I noticed is this very strong peak around 1700. And that says right away that this molecule has a carbonyl. But in addition to that, I see these 2 peaks in this sort of 27 to 2800 region. And you should recall, that's a region where we don't see a lot of infrared peaks. In fact, one of the only things that we see in that region is specifically if we have an aldehyde. This CH bond of the aldehyde gives us 2 peaks right in that region. So this IR spectrum suggests that we have an aldehyde. Just like the previous spectrum, the spectrum also suggests that we don't have any OH or NH protons. So at this point, let's see where that gets us. And looking at our list of compounds, there is only one aldehyde on the list, and that's compound F. Moving on to our fourth spectrum. This small peak up here in the low 2000s, we know we see that when we have an sp carbon. So typically looking at either a nitrile or an alkyne. But before we even go to the list of structures, we also want to look at this peak. 3300, strong peak, sharp peak. We know that's our terminal alkyne. So we can pretty much rule out the nitrile. We can be very certain that we have an alkyne, and even more certain that that alkyne is going to be a terminal alkyne. There's two alkynes on the list here, E as well as K. But E, the alkyne, is internal. K has a terminal alkyne, and that tells us that this has to be compound K. Finally, our last spectrum has only one important peak. Just above 1700, it shows us a very, very strong carbonyl peak. So if we look at the possible carbonyls on our list, and there are several of them, A, C, L, and G. How can we distinguish between them? Well, compound A has an OH group. Compound C has an NH group. If we go back to our spectrum, we can see our region for OH and NH has nothing there. I'd also like us to note that our carbonyl peak here is just above 1700. So if we go back now, we know there's no OH, we saw there's no NH, so we're now left with G and L as the two possibilities. Compound G is an acid chloride, compound L is a ketone. Just above 1700 is our typical range for a ketone. Something like an acid chloride, though, which was compound G, is much, much closer to 1800 wave numbers because of the electron withdrawing chlorine group. Given that this peak here is definitely closer to 1700 than to 1800, we can make the logical conclusion that it's not the acid chloride, and it is therefore compound L.